In this video, we're going to talk about what it means to be a polygonal number and look at a few examples. A polygonal number is a positive integer that we can represent using a regular polygon. Let's look at triangular numbers. A triangular number is a number that can be represented by a three-sided polygon, in other words, a triangle. The first few triangular numbers are 1, 3, 6, 10, and 15. 1 would be represented as a single dot. Here's the representation for 3. Our representation for 6 would look like this, and so on. A triangular number, t sub n, can be represented as the summation of I from 1 to n, given by the formula n times n plus 1 divided by 2. So let's take a look at how to apply our formula when n equals 1. Then we would have 1 times 1 plus 1 over 2. That gives us 2 over 2, which equals 1, our first triangular number. If we plug in n equals 2, then we have 2 times 2 plus 1 over 2. That gives us 2 times 3 over 2, which is 6 over 2, and that's equal to 3, our second triangular number. And if n were equal to 3, then we would have 3 times 3 plus 1 over 2. That would give us 3 times 4 over 2, which is equal to 12 over 2, and that equals 6, our third triangular number. So as you can see, triangular numbers are fairly straightforward to calculate given some positive integer n. Now let's take a look at square numbers. A square number is a positive integer that can be represented as a square. It's given by the formula s sub n equals n squared. So our first square number, if we let n equal 1, would be 1 squared, which is equal to 1, and this would be our representation. If we let n equal 2, then we would have 2 squared, which is equal to 4. And as you can see, we can represent 4 as a square polygon. Similarly, for n equals 3, we would have 3 squared, which is 9. And the polygonal representation would look like this. A pentagonal number is a positive integer that we can represent as a regular polygon having 5 sides. The first few are 1, 5, 12, 22, and 35. Pentagonal numbers are represented by the formula n times 3 minus 1 divided by 2, where n is a positive integer. If we let n equal 1, then we would have 1 times 3 times 1 minus 1 all over 2, which equals 2 over 2, and that gives us 1. When n equals 2, we have 2 times 3 times 2 minus 1 over 2. This gives us 10 over 2, which gives us 5, our second pentagonal number. And so on. A hexagonal number is a number that can be represented by a polygon with 6 sides, and its formula is given by h sub n equals n times 2n minus 1. The first few hexagonal numbers are 1, 6, 15, 28, 45, and so on. If we look at the first couple, when n equals 1, then we have 1 times 2 times 1 minus 1, which gives us 1 times 1, and that equals 1. When n equals 2, then we would have 2 times 2 times 2 minus 1, and that equals 2 times 3, which gives us 6. As you can see, the formulas for polygonal numbers can be fairly straightforward, and the polygonal numbers themselves are fairly easy to calculate. I hope this example was helpful, and we'll see you next time.